Hello, hello. All right, we're back. Okay. Been a little bit sick lately, so there's been some off time here. But now we're back, and let's see where we are. Yeah, so that's right. Last time we did some work on mutable variables. That seems to work now. Yeah, I was talking about the executable calls, making like a struct thing for storing data regarding executable calls, and creating a context when binding to blocks calls that is stored in memory. Let's see if I remember what I meant here, or if I can understand this properly. Create a context when binding to blocks calls that is stored in memory. Oh yeah. So basically about the standard I/O, it's like if you bind something, I still have it here. So if you bind something like this shouldn't actually get echoed out to the terminal. It should be stored in memory instead. And so it's kind of like this inner part is gonna be ran in a separate context. I still have to figure out though how to exactly do that with this new setup. So if we run this, it's not gonna. Shouldn't be printed out. That's the thing. Okay, and in order for to have this, I think I wanna make it easier to deal with structs. Right now we do have like kind of like structs, but not really. So I mean, we have the potential to have structs though, but create a context when binding blocks. Yeah. So kind of like the value that we bind to is gonna be the struct, and then also we need a way to create this context and have the data be stored. Basically, I guess the data needs to be stored in like in memory, like on the heap or something. Yeah. Well, actually, you know what? I mean, since we're in the virtual machine, we could just utilize Zig's memory as well. We could just say that, okay, well, let's say we got some data from standard out. Where is that stored? Well, that is stored. We can just store it in a zig string, and then that will kind of be like magical land outside. It could be like a magic pointer, I guess. Because we don't, or I mean, yeah, it could be just it could be a separate kind of value, because we don't have yeah, it could be just like a runtime only value type thing, because we don't really have like the memory in the virtual machine is not really like a byte it's not a bunch of bytes. It's a bunch of these values. So actually, what we could do is have one thing that is not supposed to be. Well, it's only supposed to be in the runtime. So actually, we could do. Let's just say it's like a zig string or. Yeah, whatever. I'm just gonna say it's a zig string. Alright. We're cheating a little bit. Because this doesn't really... This moves away from the kind of the assembly-like thing. And we're kind of using like a magical thing for this. But we could do a zig string. We could also do... What do we actually store is the question. No, well... That's probably just gonna be a string, yeah. And yeah, it's not actually gonna be here. So I'm just gonna say this is a compiler error. Okay. And of course, here is just gonna be that. I forgot about the reference trace. Reference by format IR value 16. Okay, so this would be like an S. I don't really want to. Well, okay, we can do this. And we can do like, I want to get, I guess, I don't know, 10. And then if S is more than 10, then this would be an ellipsis, otherwise it's empty. That's All right. Okay, so right, so we have these strings now. Now, what do we do with those? So when okay, as always, we go back here and we're gonna figure out what kind of instructions would this turn into. And well, the normal instructions, if we just had this here, this would just be I'm just gonna pseudocode it. It's basically gonna be like setup closure for, well, okay, we don't really need that right now though, but yeah, because this doesn't use any variables or anything. But it's basically gonna be push arguments to the stack, and then exec, and then wait. So basically that is basically what's happening here. I mean, there's some other things as well, because this also, this is happening inside another threads actually. So this is like forked. I'm gonna do this to say that this is what's happening in the fork. It also has, actually no, it doesn't have a streaming thing because it's not part of a pipeline or anything. No, yeah, this is the only thing that's happening here. Basically, let's just double check this actually, because we can just check here. Alright, let's get rid of that. So here's the instructions. So basically, let's see. Yeah, the closure we don't really care about because there's no closure. Alloc 0 is kind of funny. Doesn't really matter. Yeah, and then let's see, and then we fork. And the other thing is just waiting for that. So basically it's just a fork. And then over here we're pushing the arguments. And then we exec and then we wait. Yeah. So that's it. That's what's happening. And then, but what should happen at this point? Well, this fork is basically, it's inheriting the standard IO. But what we need here is not that. What we need here is we need to create a bunch of pipes that will store the output. Well, standard in is still inherited, I guess. But standard out and standard er will have to have pipe. So we actually have to create like a pipe for standard out and a pipe for standard er. And then those would be used here instead. So standard in is like inherited. And then this would be like pipe standard out, pipe standard er. So basically we create these ones and we set you to be a new pipe. Actually, yeah, I think the pipe instruction, I forgot. You can actually have a location there. So actually this would be pipe, create a pipe at standard out, create a pipe there, Alright, and then those are put to this fork here. So now we have these pipes, which are basically just, they are kind of like buffers. They will accept a bunch of data and store it in memory. But they are not like, we are not connecting them anywhere. And so also I think we need to read from, we need to kind of read from this. We need something that reads from standard out and standard error in order for this to exit as well. So I'm gonna say, yeah. I'm gonna fork. So this doesn't matter. Standard out. Well, actually, the thing would read. Okay, let's just do this. Standard out. So we're forking. We kind of, this is forking the stream standard out, and this is forking stream standard error. Okay, which will basically do so that this will read from its source until the source is done, and then it closes basically. This will also do that. However, we want to do that basically after this fork, because now actually we could do this. We could set options. So option, we set keep open. Yeah, they should be kept open until we're over here now. But the thing is, we can't really adjust what's happening in here. I guess we'll do it down here. So here, no wait, that doesn't work. One second here. Because the things happening in here is from compiling this. So we can't really modify here. What I wanted to have is like, after we've spawned and connected the pipes, then I want to turn off these options here. Another way would be to fork these after, I guess, and then we don't need these. So first we fork this, then we fork these. But we still have the same issue though. Wait, we're actually, I don't think we're waiting in here though. No, we're not waiting here. I'm pretty sure. No, wait, we are, because otherwise the fork would just exit. Yeah. But we have no way of knowing when we reach this step. Okay. Well, I guess we'll figure it out. I'm gonna put these up here just so we can see if there is actually a race condition. I don't actually remember, because I think if you don't keep it open and you start to stream, it's gonna say it has like no connections. If we have a destination, we don't have a destination, and we don't have any sources. Then we return no source. If we go to evaluator and stream, and this has no source, then it's waiting for that. Okay, so then that should be fine, I think. Okay, so it's fine. So it's gonna get connected here. Here is where, well, it's gonna get connected here. When we execute the executable, it's gonna be connected to this. It's gonna inherit standard in. The standard out is gonna be connected as a source to the pipe here, and same with standard error. So the output of exec is put into these pipes. Okay, so now they should have a source, but they still don't have a destination. But that's fine, because even if they don't have a destination, we can still read from the source and buffer it. Okay, so that should be good. And then we wait. Then once the sources are closed, once these are closed, these will close kinda as well, and the execution will stop. This will go on. Now we get this fork. We also want to wait for this fork here. I'm not sure if, because yeah, that should either happen like that should happen automatically actually, so I don't think we need to worry about that, because it's like part of the statement compilation part or something like that. We'll see, but this should be it. And then at the end here, no wait, we do need to do some more stuff. I think since we know we're working with like we're binding here, we can wait for this. So we'll wait for that fork, and then here we'll know that we now should have these populated. So then we can say, now we can create our struct. So let's see. I think we're gonna like allocate how much do we allocate? I think we just allocate like 2. So that is going to be our struct here. Here's where we create execution context, or execution result. Actually, we need 3. Okay, so one is for standard out, the other one is for standard error, and then we have one for exit code. Just not sure how exactly we're gonna get those things. I mean, we can set like the first to be the buffer there. So basically we need a new way to, yeah, we need to be able to reference fields, but I think we already kind of have this, but this is a pipe though, so it's kind of different. This is kind of like a dereferencing the stack and then accessing. No, it's not actually, because this is the value in here is not like an address. The value is a pipe handle. So I guess actually, you know what? We could just have the pipe handle here. We could just keep the pipe around. Yeah, I think. Although then it can't be stored on the stack. It has to be stored on like the heap. But let's not worry about that for now. Let's do like, well, okay, so this is just going to be pipe standard out. And then the second one is going to be, and then the evaluator would have to know how to kind of wire this up. And then this is going to be, so this will be the exit code, but we don't actually have that here, which is the thing. Because when we spawn exec here, we don't, the process handle is like local kind of here to this fork. Well, I mean, it's produced here in the register of this fork, and then used in the wait, but it's not, we don't pass it out. So we out here we don't know what the process handle is. So the exit code, we need it to be able to know the exit code. Hello, Mohammed. What language is this? The language that I'm making is called Runic. And then this, what I'm doing here, this is the kind of the IR language, you could say, or bytecode or whatever of the language, which is kind of like a more detailed version of what's happening like under the hood, sort of. And I'm trying to figure out, in order to support this thing that I'm trying to make here, I'm trying to figure out what I need to do in order to support it, basically. Because the thing is, we don't have a way to return things from a fork. What we could do is expose a value on the heap in the closure of the fork. and I use that as kind of like a return value. Because what would be good to get is the actual handle of the process, so we can get the exit code as well. Because that is like lost right now. We don't get that. There's just so many things happening for a seemingly simple thing. But okay, let's, I guess we can do like ref process handle we add process handle to closure. Okay, I'm gonna say like closure process handle. That gets forked. The closure is like consumed here, I guess you could say. This is also like mixing a little bit of pseudocode in there as well. This is not exactly how the IR looks. I'm just trying to, you know, at a slightly higher level, figure it out first here. What am I building here? I'm building so right now I'm working on a bash-like scripting language. Now what's happening right here is basically trying to figure out how we can make this happen here. And so this language up here is called Runic, which is kind of like it's the bash scripting language that I'm trying to kind of replicate in my own syntax choices. So here we're binding E to some expression here which calls echo with this argument. Okay, and what's happening down here is basically this kind of compiled to bytecode or an immediate representation of this code up here. So I'm kind of making two languages at the same time. I'm making this language, which is like the more higher level language, and then I'm making a lower level language that is making it happen, basically. This is the language that kind of gets interpreted. The thing is here though, that this echo, normally we just return, this expression is like results in this fork, like the thread handle. But now we need the process handle. I guess we want both. It could be a struct actually that we return. So we could do this. We could allocate to, and then add that to the closure. And then in here we will say, okay, set. So this will be like closure. Plus, well, it's gonna be whatever this is, and we set that to R, and then the fork is grabbed out here. So here we actually need that as well. So here we're gonna set Well, now we lost that, so we need to push R as well. So we're pushing R, and then over here, I guess we'll wait for it, and then we can pop. No, wait. No. Well, actually, we'll create a ref here. Ref execution results. Actually, this is kind of like execution handles. Okay. And then we set that to be the pointer we get back from alloc. We add this to the closure so that this can then set that to R. Actually, what we could add is like this dereferenced, so we get the pointer. No, no, it's still the first one there. Yeah. Okay, and then down here we're gonna set. Whoops. So we wait. So this is really waiting for R. I'm kind of pseudocoding a little bit as well, but really the full instruction here is wait and then R, because R is returned by fork to be the thread handle. And now we can say I want to set execution handles +1 to be equal R. So that is the thread handle. So now execution handles is going to be like the first execution handle is the process handle, and then the second one is the thread handle. So we have both, and they are returned. Actually, this doesn't work because this happens outside. Yeah. So it has to be like this. Yeah, but that's fine. So we do that, and then we wait for that. So basically, all execution expressions will now include basically all of this here. Yeah. And I think what we'll do is we will... Yeah, we could just return then the ref, actually. Yeah, we'll just return the ref. That's fine. And then actually down here is like we don't really wait for R anymore. What we do wait for is like execution handles +1. That's what we're waiting on there. Yeah. Because this part over here is like after. This is compiled after. So basically this part over here, this is the exec instruction, or this is like echo here, execute like compilation, and then this is like end of echo compilation, right? So this part is like a, I don't know if this is the correct term, but basically I'm calling it like a compilation unit. It's like happening together. This is like the compilation of the echo. And I'm just trying to make it as usable as I can to other things to use the result. And then all of the compilations also have a result, and the result in this case is kind of it's gonna be like, you know, return execution handle. So that is the result of this compilation. So then other things that's gonna use, for example, over here is using this ref to be able to wait for the fork to be complete. And now over here we can just add this +0 to get the process handle and once we have the process handle, we can get the exit code. So now we have built up the execution result here. So this is the whole execution result. And then later, if, for example, we were to do this, for example, we can now see that, well, we have a thing here which is it's gonna be like a struct, actually. I'm just thinking about how to turn this into a string, because it's like, for now, like right now, if we encounter a heap pointer like this, we just interpret it as a kind of like a rope, where each element each element in the allocation is treated as something that can be materialized into a string. So we're just looping through, and also the first element says how many elements there are. But this is different. This is now should be treated as like a struct that is different. But when we run this in the evaluator, we don't actually know that it is a struct. We would just have to set up the instructions such that it actually works. Although, yeah. So it kind of feels like we need some kind of representation of this value in the compilation that knows that it's this kind of struct, and can like handle certain tasks. For example, in an interpolation, to be able to turn it into a string from there. I'm not actually sure. Man, that sounds complicated though. I mean, yeah, okay, I might need more. I don't know if I need like more abstract things. For this. Because it seems like, let's say we have other types of structs as well. Other things on the heap, it doesn't have to be string ropes, whatever. It can be anything. And if you want to be able to materialize those into strings, then it makes sense to, let's say you have some kind of, toString method, or, something of that nature. Some kind of way to handle all structs, basically. But the thing is, here in the virtual machine, we don't actually know what it is, and we don't really have a way to kind of peek in and see, okay, should we just treat it as a string rope, or can we treat it in some other way? I guess, one thing we could do is like, we could put the type in here as well. But it just feels like this should be able to be handled in the compilation stage. But that does make the compiler more complicated. Because then it's like, okay, well, when we compile this expression, we have to know the context of it. Like, we know the context is like it's trying to be interpolated as a string, right? So in the end, this expression needs to be kind of converted into a string. So we need to kind of look at what type is this, and then choose the correct transformation to turn it into a string. So when we then use it, let's say we do this one. So this would be like one of these. And well, this would be inherited. So, and then we got the arguments. The arguments, like this, the first argument here, or the only argument, that's just gonna be like it's gonna be this thing here. So it's gonna be like, well, let's just say we have execution results plus 0. Yeah, it's just gonna be that, and that is a pipe. The pipe can be materialized into a string, so that's fine. But it's like when we have this thing, like a struct thing type thing with several values, that's where it's like, okay, well, how do we turn this into a string? But basically, the compilation might know that, okay, well, this is the thing you need to push. Okay, let's do that. So that's fine. All right. I mean, I guess that would work. Now, but for that to happen, as I said, like, we need to know that this compilation needs to be the context needs to be like, yeah, this is supposed to be turned into a string. And so so what is happening then? It's like we're referencing E, right? So we're not just taking, so if we referenced E, normally we would just, this would be the value of E, right? But now we know that, okay, well, this is like a struct that has some kind of thing there. So I guess the compiler would have some kind of toString or queries to string or something method that would take a result and turn it into like the best way to represent it as a string. I'm not sure. Does that say Privyet? I'm not sure. I'm not. I don't read Cyrillic. But hello to you, if that's the case. I'll just BRB 1 second here. All right, I'm back. Sorry about that. Just making some coffee. All right, so let's see. Okay, well, I think we have kind of like a plan here. But we're kind of solving two issues in one here, because this part is not really needed right now, like the execution result is, but I mean it will be needed later. We do want to be able to look at the execution result, of course, so that's good to have. Yeah, all right, so great, but that also kind of makes it so that this part is like, I mean, it's both like a, it's kind of like, well, it's like a natively known, or native is the wrong word maybe, but it's like a compiler known, built-in, I should say. It's a built-in compiler known like struct type. So we would know, for example, how to get the exit code out of this struct thing. The compiler will know how to use this, basically. But yeah, anyway, so if we get this in place, we should be able to do these things. Okay. So I think the first thing that I want to do is modify the execution compilation so that we can support returning this execution handles instead. However, I feel like we probably want to put this on the heap. Probably. Instead of the stack. I'm not sure actually. Because it's like something about this, like returning. This could be returned from... No, let's just do it like this and we'll see. Okay. So let's go to the compiler. Compile executable. All right. I think I'm just gonna remove this because I don't even remember why we have this. Yeah, it's when the call context was like a struct, but it turned out to be way more inefficient to have it like that. Instead, now we just push a bunch of things on the stack and that's fine. All right. So what's gonna happen here? So we have our execution set. We are creating a closure here. Now, and so this is what we're looking at. And then at some point we have the fork. Where's the fork? At fork is somewhere. Oh, here. Yeah, so there's the fork, yeah. All right. So what we need to do is like, yeah, we need a ref. Sorry. For the execution handles. Execution handles. All right. And we also, okay, yeah, we are, okay, okay. I forgot that we are actually putting it on the heap, so it's just that we have it on the stack here as well, so we can reference it more easily. Okay. Sure, it is on the heap because we need more than one thing, so we're kind of using it. Okay. I mean, technically, we could also have 2 stack values instead of putting it on the heap. I think. Or will this be... This won't... No, because then this won't work. Yeah, we need... It's kind of like we need mutable variable. We need a mutable variable for this one. Yeah, okay. Anyway. And then we need to allocate 2 Alright. And then we need to set execution handles to be from location or register, because alloc will modify R to set to the pointer where the allocation happened, and then we can use that to set this to that location, to the pointer. So now this points to the heap. So it's a stack. It's kind of like a stack pointer that which content is pointing to the heap. Okay, and then yeah, and then closure. Right. So then we want to now sort of, it's kind of like we have like a magical variable we want to add to the closures. And I'm not really sure how we do that, actually. I mean, we have like declare closure, but that is kind of requiring us to declare it's kind of like we need to declare a special thing here, but also names are unique. So I'm not actually sure what we do here, if we need to introduce a new concept here. Like a special name that is reusable. I'm just adding weird complexity all the time. I'm just gonna call this @result. And it's gonna be so what is this right now? This is it's gonna be a mutable we could basically just make up a binding though, I guess, as well. No, yeah, no, yeah. So this one, allocates, right? So we actually do allocate, but that, yeah, but this is the actual compilation here. Allocate. We set. What do we actually return? Oh, this doesn't return anything. But what do we declare? That's the thing. So if it's a constant, we just declare. Right, that's the closure. Right. I'm actually not sure. No, is no. Okay, let's go back. Compile. Let's go back here. Because it's like it's mutable. So what we do is we allocate, and we set. And we store the result. Right. And this sets the closure. Location to the pointer of the thing. Oh yeah, because it's added to the local closure as well. Yeah. I think we need to do all of these things. It's just that we don't have an expression. We have like we want to do basically this part. It's just that we don't want to compile an expression. So I'm gonna move this to like compile mutable something variable. And basically gonna do this. Identifier mutable is true. Source. Alright. Actually, identifier. No, that's fine. Yeah, the identifier, yeah. That's fine. I'm gonna add a new thing here, global. Now, instead of doing like that, we're gonna do compile variable Identifier is going to be global results. Right, so what do we set it to? The value. Oops. No. Okay. Hello, Penguin. Welcome back. What's up? What's up? Hope you're having a good day. Member function expected 3 arguments, found 2. Right. So the value. Well, actually, yeah, the value right now is just void. Wait. No, wait. Hang on. No, it should be like a pointer to. Yeah, it should be a pointer to the struct. So it should be. Yeah, it should just be like this. Or just execution handles, but yeah. Okay, cool. I mean, really, this could be like a global variable, really. It's kind of what it is. It's kind of like a global mutable variable. But that doesn't really work, man. This is... Oh, it needs to be... It's sort of... It's weird. Because it's like... We're creating it here. Maybe we need to generate a name for it, actually. We can do that, maybe. But then this needs to take the name. But that's fine. We have it because it's in the same compilation thing. Yeah, I guess we need to generate a name. Okay. Okay, let's do actually, you know what, let's do this. Let's do like result variable equals self compile result variable. I'm just gonna do a convenience function here. Source the value we can still, I guess, put there. Put you here, so this would be not that it was much of a difference. Oh yeah, and then you need like that. And yeah, so now we need a name. At result counter actually or do we just return a name actually? I don't know, man. Yeah, sure. And it's gonna be name. Alright. Now we need the result counter. Where is the thing? Result. All right. Hello, Subida. What's up? Welcome back. How's it going? All right, cool. Yeah, I mean, it's going pretty slow, to be honest. Like this, I'm not sure if the IR thing was a good idea. I thought it was gonna be like not this difficult, actually. I mean, I didn't think it was gonna be a breeze, but it's like, yeah, we'll see though. We'll see. Maybe we can trudge through and get to some good place in the end. We'll see. But yeah, it's starting to like slow down significantly. Like something that's kind of is like, oh, well, this could be hard, but then it was like super easy. But then it was like these weird things that seem very simple are actually super hard. But I think it's mostly because of the thing that complicates it is basically how I built up the virtual machine, and well, how kind of things get spawned, and we have the virtual threads and all that. So that's where the complexity comes from. Because if it weren't for that, then we could use more stack-based things, and yeah, because right now it's like, yeah, I don't know. It just seems like complexity grows and grows all the time. But I'm trying to fight it though. All right. But anyway, let's just see how we can make this happen. So yeah, this is the name, and now it's like the closure. Actually, yeah, the name, and we just add it to the closure, I think. No, we don't even need to add it to the closure. What we need to do is to say what do we need to do? You know what? Let's actually return an identifier instead. And do we have an arena? No. Okay, whatever, it doesn't matter. I think everything here is in the arena anyway. So yeah, that's the name. I'm gonna say identifier. and then we return the identifier instead. Alright, so now this is an identifier, and now let's see, we can do so here's pushing arguments. Okay, what's happening here? Yeah, we need to, after the execution, we need to add a set here. So we need to do set, and the location now is actually gonna be results. I'm gonna say well, this is like the name, and then over here is like the reference to the closure, I guess. So this would be compile identifier, because what this will do is it will say that it will mark this identifier as being requested from this context, from this thread. So it will wire up the closure correctly so that we can now access that. And then we can actually use this to set here. So this would be from location, I'm pretty sure. Oh wait, no, that's just results. No, yeah, so this is just result.source. So we set that, except do you need to be, you need to be a location, yeah. Location. Yeah, because that will be the closure location. And I think we want a dereference. So let's just do that. And then we set that to the handle, which should just be R there. Yeah. I think it's slowing down development process, right? Yes. I mean, like, I chose this path when I had like a fork in the road, because the original issue was to solve like streaming pipes when you have like a block like this that is piped into something else, you know, something like this. Okay, so it's like the whole issue here was that we needed to be able to suspend. Well, okay, this example is, but if let's say we did this, so the whole issue was we needed to be able to suspend execution, because these things need to be run sequentially, right? First this should happen, this shouldn't start until this is done. So this should execute first, then this, then this. So it's kind of like a sequential thing, right? So we need to like run this, suspend the execution of this block, but we still want to be able to stream. We want to set up the pipes and stream them out to grep here in the meantime. Now there could be, there's probably easier ways to do this, but I was like, hey, IR is good at, you know, suspending execution. You can just do it like it, or I mean IR, I say IR, but I mean like assembly, really. like assembly, because it's basically like a list of instructions, and you just have to stop at where you are. You don't move forward. So it's like assembly is good at suspending execution because it's like context based. So everything you need for it to continue execution is kept in the context, and so then you just step through the next step. So that is like one of the reasons why I wanted to do it, so that it's very easy to just suspend the execution here, keep on streaming, and once this is done, we keep on, we continue here. Another thing that was good for is virtual threads, because instead of just having one thing that steps through, or I mean one thread that you step through, you can have a list of threads that you kind of, I'm kind of doing like a round robin thing where I just loop through, or not really loop through, but when you step, there's a thread counter that says that it's kind of like an instruction counter in assembly, but it's pointing towards the next thread that is supposed to run. So for example, first you have the main thread, and then you call step, so that will run the first instruction of the main function of the main thread, and if that spawns other threads later, then those will be sharing, as well. So you call step, you execute this, call step, execute this, and so on until you fork. Now you have two threads. Okay, now next step will be the next thread, and step again, you will continue with the main thread over here, where these indented things are like an easy way for me to represent what's happening in this fork here. And I'm calling it fork, and I realize that's also kind of misleading as well if you're used to like forking in Linux. It doesn't really do the same thing here. I'm just doing it because what it's doing is spawning another thread, but it's also jumping to another place. So it's jumping into this instruction set here. It's basically calling this function almost. But yeah, so for those reasons, why wouldn't we need virtual threads? We need those to be able to stream simultaneously as we are reading and writing data with the pipes that's going on. Also, it will help with async, the pattern fits, I should say, with async execution, or like coroutines, basically. And also the debugger would also probably not be possible in an easy way without this as well. So there's a lot of bonuses to this, but it also increases complexity a lot because I basically need to invent this new language at the same time, and also figure out how to compile to that and have that also being executed at the same time. So yeah, it's like, but then also like it's like some things are actually way easier to do in this way, while other things are harder. And as I said, also I think most of the complexity comes from the fact that these virtual threads, like how they work, and the reason we need them, and also that you can reference things inside other threads. So for example, here's a variable like declared in the global scope, you could say, but here it's referenced in here, which actually happens like in a separate virtual thread. And the way it's shared is that this virtual thread now has like a closure thing, and so that it's like there's a closure stack, sort of. So this points to a place in this thing's closure, which then points to where this is. So yeah, so because of the how that works, it kind of makes it a lot harder to do it like this. Well, or I mean, it complicates things. But then we can compare it to, because I already implemented this in the other way that I had before, which didn't use an IR. It just took the AST and evaluated it directly. And then this type of thing was super easy there, because we just declared E as a variable. This was actually just ran and stored here. We saw that, okay, this is a binding, so this would be ran in a separate context. We also used context there. And this is what I'm doing here as well. I'm kind of building it up. It's just that it was easier to think, like, I guess it's easier to think like in Zig how you would do it. Now I have to think in how to do it in this new language that I'm making up at the same time. So I guess that also adds to the complexity, because, yeah. But basically I'm just redoing the same thing. I just have to do it in this new way now. Which sometimes is actually way easier and sometimes is way harder. And in this case, it's a little bit harder. I'm just going to grab my coffee here. I'll be right back. All right. Also, I can. No, let's see. I just wanna check something here. Oh, anyway. Never mind. Let's see. Alright. Hello. Not cammed. What's up? Welcome. Alright, so where were we? I think we were trying to do this, or did we already do that? I don't remember now. Yes. Okay. So I think this would be the thing. I mean, it's either gotta be like we have to dereference, because I think it's, yeah. Let's just do that and we'll see what happens. Either it's gonna overwrite the pointer here, or it's gonna go grab into the pointer and set the first thing there, which is what I want to happen, but we'll see. If we can't do it like that, we actually have to kind of store the pointer. We have to do like a double dereference, and that complicates things, because then I have to kind of reuse or... So anyway. Oh yeah, also... No, but that should be fine. Okay, cool. So, what if we just... I mean, okay. I just want to do this first. I just want to say, okay, echo hello world. What does this compile to now? Are we compiling at all? First and foremost, no, we're not. We have some issue here. Location, found result. Oh yeah. Okay, let's just do like source location, because we know it's supposed to be a location, and then I'm gonna dereference that. There we go. Expected value source. Okay. Now I'm gonna build. Okay. Okay. I mean, it works, so that's good. Let's just see what's happening here. We got our execution handles ref. We allocate. We set. That's to R. Okay. I could step through the debugger as well, so we can see that values are like the same, or that the values are correct as well. So this part is the execution handles, yeah, and this part is the closure. Like this is like the mutable variable. This looks weird. Wait, we're setting it to R? No, okay. Wait, C plus 0. Okay, yeah. C plus 0 is R. Right. What is happening here? Oh, because the... No... Yeah, okay. Because the value... Because the... Okay. So actually... The issue is that we're setting it to R, but the problem is, in the process of doing this, we're using R. So you... No, yes. You are there. Oops. Wait, did I not add this back to the other place? Oh. Okay, I just ripped it out of there and I didn't add it back. Great, there we are. And then you are result. No, result.source. Okay. So really what's missing is this part here. It's like, yeah, we want to check if it's R, if we're trying to use R. So I think I want to add this here, but then it's like a double thing. Maybe we'll just take like all of this and do like compile identifier bind or declaration or binding without the results being compiled like this. Okay, let's do that. Let's do like this should be like, well, I guess we could still have that maybe. And then we'll move all this out into like compile identifier binding. Source identifier results and is equal. Okay. Left. identifier and results or value. Let's just do like value source. What? No, AIR. Value is registered. Blah 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 blah. Oh, right. Oh, yeah, that's right, that's right. Actually, no, we can get this value in, and then we can get a result out. And I will say that, yeah, this is a result, and the original result is like that. And then in the end, we will return the result. Oh yeah, we need this mutable. And I'm gonna put this there. Wait, this isn't even used here though. We don't really care about the thing, I guess. Okay, whatever. Well, we do want it locally here because we send it in here, but we don't need to return anything. Yeah. Okay. And you should be. So that's that. And then you should be source. And you are now compile identifier binding. Whoops. And then everything is the same except for the last, which should be true. Okay, so now we should also take into account if it's like if the value we want to store is the R register. In that case, we kind of handle that. So there we go. Now let's see what happens. Still works. Okay, so now we get this identifier ref as well, and that gets set to R, which should be whatever, like this pointer that we're storing here, the heap pointer. Alloc1 is for the mutable variable, the result variable, and then we set that to be identifier ref. We're dereferencing R, yes, or I mean we're dereferencing the identifier ref. Wait. Yeah, okay, whatever. Let's just assume it's fine. Actually, you know what? Let's actually just step through this so we can see exactly what's going on. So we have one thing on the heap now, which is the mutable variable. We have execution handles. We allocate 2. We set that to that. Create a new ref. You can see here, this is, I should really add like annotations here to see, because we do have the refs. Maybe we can actually hook that up. So this part, so it points to the same thing. Yeah, it's just a temporary to store R. We allocate one for the, wait, we allocate one. Okay, sure. And then we set that. So now R, which points to 14, now set to that. So actually, let's take a look at that. Let's take a look at 11 and forwards. All these are void. 14 is set to 12. So that should be where the mutable variable is located, I think. And now we're setting C plus 0 to R as well. So that should set like, yeah, heap 11. That should set the first one. Oh, that's set to here. Okay. It feels like we have double pointer, too many pointers going on here. Okay, but then we have like the closure thing, and we allocate. So now we're allocating the closure. Right, okay. R plus 0, C plus 0. Okay, yeah, so we're copying the closure. So actually now let's take a look at this. So, right, so 14 is the pointer to the mutable. This is the mutable's value, which is a pointer to 12. Okay, yeah, because it's a struct. Right, okay, it makes sense. It makes sense. Yes, that does make sense. Okay. I mean, I guess it could just be a pointer to 12 directly though, but whatever. We'll see. Okay, and now R, which is points to 15, is set to, well, R is, we're just using R to set it to some, back to where it was before. We fork, and here we're pushing something there. So really what I'm interested in now is seeing, we execute, and then now we're setting C plus 0 equals R, right? So C in this case is 15, as we can see here. It's the closure address. 15 points to, so the first item is here. This is the result thing. So what value, we should expect 14 here to change. But really what I want is 12 to change. Hopefully that's what's gonna happen here. Okay. Okay, it didn't. So that's wrong. So it actually like overwrote the pointer to the struct. So that's not good. But we did get the handle to the executable, so that's good. But yeah. Now, I'm not sure if we can reduce the complexity here, because we have like one space for the mutable variable which points to where the struct is. It's kind of like, maybe we can say like, okay, well, when we create the mutable variable, could we also decide the size of it? Because then it's stored directly instead of being another pointer that we need to dereference. That would be good. But then we have to handle basically all scenarios in which that happens. So it's like, well, this is happening from closure, obviously, or binding. So that's happening there. Yeah, the thing is here, we need this value. It needs to be like compile time known what type it is. Well, we do have that, but we need to use that to be able to know the size of it. In that case. Because, yeah, if we go in here, we see we have a value. Okay, the value could be a struct. And we have the type. We can like get information about type and stuff. So that's all. We can do that. So it doesn't need to be like a built-in another like hard-coded struct type. It can actually be like a dynamic thing. But then also it's this is hard-coded because it's one of the built-in struct types. So but anyway, how can we do that? So okay, here we are saving that, so that's fine. Here we're creating a bit, so it's really only in here which we need to worry about that, I think, because this is where we need to kind of take it from compile land and make it into like an actual thing in the virtual machine memory, which was why we have allocate 1 here. So the struct value, I mean, this could be fine though. It could be fine. It's just that when we set the thing, we need to know, okay, where is that? Compile executable. So it's like when we set here, we need to know how to where to put this. So yeah, we need to double dereference here. That will fix the issue, but it also just moves the issue. It just pushes the issue away that we have as well. Because we don't really need to have like a double pointer. No, let's just do it. Let's just do it here. So we need to double dereference, right? So R is volatile. So this is volatile. It's stored in R. This is fine. This is just a name, or wait, no. No, yeah, this is just a pointer to closure here, yeah. So what do we want to do? Let's do, should we push? Wow, we could just create, I guess we could just create a ref here. This would be like results. Temp. Oh. Dereferenced ref. Alright. So then we set. No, wait. I'm just gonna store. I'm just gonna save R. Alright, so we set that to that. And now we can use R. Here we can restore R. So here we can just do pop. And that should be fine. Because pop modifies R. So this is usable again. Okay. And now we can use R. So we set R to be this. And now we can say init register R dereference. Oops. Why does that not work? Can't you do like double? Because this is like an implicit declaration. Is that the what if we can do this? Now it's like not. Is that why? No, but we have all these things. And this is a location. Weird. Okay, let's just do init absolute dereference true. And yeah, we want to set the handle. Wait, but now we don't have the handle. But we want to set it to. Actually, let's just call this exit handle ref instead. Yeah. Because now that's fine. And we don't really need to pop here. Actually, we can just use the ref. All right. Okay, now we can do that trick there. I think. No? Source. Okay, so we're storing the exit candle in a ref. We're setting the ref to the exit candle, which basically is R. We are getting the location of the identifier here to store the result. And we now do a double deref. So first we're saying that we set R to be the dereference of this thing. And then we're dereferencing that and setting that to the handle there. So there we go. Now let's see if it works how we want it to work. I'm just gonna fast forward a little bit here till we get to the fork. Alright, we execute, we create a ref. Whoops. Index out of bounds. Interesting. That's strange. Wait, hang on. Am I mixing things up here? Handles. No. Fork. Push. Set closure saved R SF plus 6 to R. That does exist, so I'm not sure why. Wait, what is SF? SF is 0 here, right? Plus 6. That does exist. Okay. Pop. Push. Wait. Okay. That's not great. I got like another result now. Maybe... I mean, it could be a race condition. It also could be that I didn't compile fully before running. Okay, well, let's just ignore that error happened for now. Execution happens. Wait. Okay, here might be the issue, actually. We're reffing exit candle. Yeah, okay, here's the issue. Plus 6. But we only have like 4 things on the stack, or 5. Why is it plus 6? Oh, this only decreases by 1. That's not correct anymore. That was correct before, but now it's not correct. It's actually dynamic depending on how many arguments we have. Okay. This should be like... I mean, I guess an easy fix is just to move the ref. But I really want to fix this also though. So this does depend... It does depend on the number of arguments. I'm just gonna say args here. And so number of it's gonna be number of arguments plus 2, because 1 is the length, argument length. The other one is the executable name itself. Okay. So now it should be correct, except we do need to add the number of arguments here. So arguments length. All right. Okay, now it should be correct, hopefully. Where are we? Push 1. Okay, because you can see here why it said that, because now we're up to 6. If this only removed 1, it would be 6 would be available, right? But now it should drop down to 3, and so this is plus 4, which is correct now because 4 is the next thing here. Yeah. Okay. And that got set to the handle, which is correct. And then we set R to be... Okay, so R is 12. Let's look at the heap. And is that correct? No, I think so. We dereference that. Okay. But it set it to 4. Okay, it set it to the stack count, or to the stack pointer. Okay, that's wrong. It should be setting to the... It should be dereferenced. There we go. Alright, there we go. So as you can see, like 12 here is the struct of the result. And I guess we don't really populate this. For some reason. It should be populated, I think. Oh, unsupported waiting. Oh, because we didn't pop. Oh my god. No, wait. No, that should be. Or do we have to dereference again as well? Yeah, yeah. I'm just doing that to make sure. Okay, but did we ever populate this? This never got populated. This should have been populated with the result of the fork. Okay, I guess we haven't really gotten there yet. What's this? Oh, that's a debugger bug. I don't really care about that. So I think what we've missed is basically setting the fork, like we're not even using this, and we're not setting the fork. I guess that's fine, maybe, but no, yeah, no. Shouldn't the result should be this? Yeah. Yeah, we're still just returning the thread handle, so that's why it works. Hello, Metallics. Welcome back. How's it going? Excuse me. All right. I guess we don't really need it though. That's the thing. But I wanted to kind of make this into like a package where you could either reference the thread handle or you could reference the execution. But I guess we already kind of do that. No. No, it's just we don't actually. It's just that we have it. Because it's created here and then we don't really return it, so the user won't ever know where to look for this. We have to return this. Yeah. So we'll return that instead, and we also need to populate after the fork. Where's the fork? Fork is here. So after the fork, we also need to set execution handles. What about your programming language? Yeah, it's going forward, although more slowly than usually right now it feels like. But yeah, we're solving issues and moving forward. It's just sometimes you get to a point where you feel like the complexity grows, and it's like whenever you do something, it might break a bunch of other stuff, and then you patch those things up, and it feels a little bit better. But then it's like when you try to like. You're trying to, like, yeah. Just as I said, like you're trying to add something, and it feels like you can break anything, and then it's like it doesn't feel good because that's not how I want it to be. Like I want it to be. I guess more simple, but I guess. I mean, sometimes it has to be complex, I guess, for it to work. But also it feels like sometimes you can also try to see, oh, I see a really nice pattern here, so let's abstract that so it gets easier to handle. Because otherwise it gets too much spaghetti, you know, too much random things happening everywhere, and there's no real reason to it, basically. But yeah, and it just makes it harder to add stuff because it's like you never know what you're gonna break, and but we'll see. Maybe we'll get out of it. Maybe once we got over the next hurdle, maybe it gets better. Maybe we can also find a plateau where we can see that, okay, well, we can improve things here and there to make it more streamlined, you know. Something like that, but yeah, it is progressing. Like right now we're back to this, but it's like I'm kind of improving how we're working with sort of stored variables and results from compilation units. Basically here now we're returning kind of like a struct pointer that we can use instead. So it's like we're improving things, and also I'm questioning my choice sometimes to actually go this route with IR, but I think it's good. I think it's it's very educational. Let's put it that way as well. Anyway, so let's see here. So we're trying to set. Have you implemented garbage collection? No. Garbage collection right now is like, that's gonna be like a nice to have right now. That is like because yeah, I think the first thing that I want to solve is basically just a basic functionality, like having a lot of basic stuff. And then since we have a heap where we put things in, we can also remove things from that and then kind of manage that. So that is kind of where I see the garbage collection is gonna come in later. But we also have to be not sure about the word, pragmatic? No, I don't know. But anyway, we have to make sure that we don't implement a bunch of random one-offs everywhere. I believe more in keeping to patterns, because otherwise it's going to be too much work on doing major things like that, like introducing garbage collection. If everything is like a one-off feature implementation, then it's like, okay, well, now it's like, because yeah, that's how it is. So but as long as we're trying to keep it clean, it should be good. But I just don't see it as being necessary right now. It will be necessary if you want to run like a long running process that's gonna loop and do like something like that. But really, these scripts are not usually like that, as I see it. Like usually these scripts are more like one fire things. So it's like, is garbage collection even necessary at this point? Like, does it really matter that much for these kinds of scripts? Like, I don't really see the value in the in going for that at the start. Other than like architectural reasons, like trying to figure out, you know, a good architecture straight off for it, because that could be a nightmare later. Like if we're trying to retrofit garbage collection into an existing system, but I just don't think it's that necessary. Is IR or threads necessary? I mean, I've talked about it a number of times, and I believe that it's as I said, like it's a solution to some of the problems that we've had. I'm not claiming it's necessary, but I'm saying that it's one solution to you know, the issues that we've had with the streaming pipes and stuff. So that's why they are there, and they are the main focus right now. I made my interpreter program to remember the first thing I created, a small 2D framework based on Raylib. It's not a framework, more like bindings for Raylib. Raylib in my program language. It works very slow, but it works. Oh, cool. Oh, so you made a program language, and then you also made bindings to Raylib? It's interpreted. Okay. Pipelines was the beginning of the end for simple code. I mean, yeah. It's pipelines, and then it's also like, it also goes into like asynchronous as well, like, or concurrent, or whatever you want to call it. But basically, you know, to be able to stream from one pipe to another pipe at the same time you're streaming to other pipes, you can spawn a bunch of things in a coroutine way, sort of. But yeah, we'll just get over some hurdles. We'll see where we land. I think it's gonna be. It's probably gonna be good. But I also think it's quite interesting, this IR stuff, because it's quite different from anything that I've done before, because it's like it's very close to assembly code, and it's very close to kind of like, you know, an IR that you actually need, that you actually want to then compile to assembly code, as far as I understand. And also it's like, yeah, but there's just so many moving parts and all of these things. Anyway, let's just finish this thought here. I want to set the, what do I want to set here? Wait, what did we actually do? Thread handle. Yeah, execution handles. Yeah, so execution handles. Now I want to set +1 here, but the refs don't have that, I don't think. So actually, we need to do this again. We need to do thread handle ref. And then we want to set that to, that's the location, yeah. We're going to set that to that. Okay, so now we have that, and then we can say execution. Wait, yeah. So now I want to set R to be execution handles the reference. So that should be no, yes, no, yes, no, yes. It's not the reference actually. I think we just set it to that because it's a ref. It's gonna not set it to the stack pointer. I don't think, or maybe it should. Maybe it does. Okay, we do the reference, and now we add one. We do like init add register R. We add 1, and we don't dereference, and we add, and we set that to the thread handle ref dereferenced. All right. Expected IR instruction values. Alright, and same thing. God damn it. The fact that you are working on the project so long and almost every day is mind-blowing to me. I mean, maybe I'm too lazy. I'm not smart enough to create work such a quick progress. I mean, for me, it's a hobby. It's like, for me, this is like, it's not a super serious project. It's just me working on my project. I just think it's fun. I've always done this. I've always created projects sort of like this. I mean, this is one of the more deeper ones, I guess you could say, like, because usually they don't last this long. But I think that streaming and all that helps in making it more quote unquote serious, or more like, yeah, going deeper. Because it's like if you only dip your toes every time, it feels like you're missing out. Because I've done that so much. Like, I've created a project, I got so and so far, and then I gave up because there was too many hurdles, and I couldn't handle it. And then I restarted, and I got interested in another idea, started on that. Cycle repeats on and on and on and on and on. It has been like that for like 30 years. So yeah, it's like, and now it feels like when I started streaming is when I felt like, okay, well, now it feels like well, it's one way to motivate to continue with a project, I would say, because I did actually complete a project once. And the reason I completed it is basically because I set a scope on it. I could see the end of it, and also there was like a very good reason to do it, because I was trying to like start a company, but that didn't go anywhere, so here we are. But I did it, and there we go. So I think that if you have like if you have some reasons, can be good to motivate you to push further in a project. And I think it can be good. It can be good to do that, of course, because it's. I think it trains your mind in a different way, perhaps. I don't know. I'm not that experienced in that, like doing all those super large projects, like going super deep, because that's what I'm trying to get into now. It's like I've done this. It feels like I've done a program so long, but I never went so deep into the project to go and do like a full thing. But anyway, yeah. Okay, so thread handle we set you to that, store that, yes, and then we set R, so we can use R now. We set. I just also realized that, you know, if we just introduced one more register, we can get rid of a lot of instructions. If we can just have like one more like general purpose volatile like register, we could get rid of all of these things. But anyway, maybe that's what we could do. Maybe, I don't know. Anyway, we're setting R to dereference that, so that is now dereference, and then we add one to that, and then we set that to that. Okay, so that should be good, but then also we are, wait, where is that used? Where's the weight? Oh, okay. It was used in the return, I think, but then it's fine. Okay. Yeah, now we're returning this instead. Right. Okay. Cool. Okay, so now it's like, what if we get this back now and wait for that? That it like, because we should know how to do it, because we would know it's like an execution call, execution handle thing, but we don't actually have that like type. We don't actually know what we're getting here. That's the thing. So either we have to introduce a special type for that, or we return like a struct type, or yeah, I would have to think about this. Maybe it's better if we just make a special type for this. Do you have registers in your IR? Yes. We have. I have the general purpose OR register, so it's just one register that is a general purpose. But it also used for some instructions set OR. For example, pop sets OR, alloc also sets OR, fork and exec. Yeah, so some set OR to be like the result of like an instruction. And then there's also the stack frame register, the stack counter register, the instruction counter register. I think that's it. When I was writing compiler for my PO, I came up with 3 AC, 3 address code without any registers, and was quite easy to implement. The registers make it faster, easier to work with. 3 address code. How does that work then? So basically, I mean, I didn't even think about other ways to do it, because I'm running it in a virtual machine. I can decide how the hardware so to speak works. But there was also a point sort of to make it sort of similar to existing stuff already, and that's why we have the stack and the heap and all that, because it's like, you know, then it's closer to kind of like what I'm familiar with the assembly. So if we were to decide to go that route, to be able to compile to actual native code, that we could, the journey to that wouldn't be as far, I guess you could say. But then again, modern compilers, you know, some architectures doesn't even have a register. So some only work with like the stack, for example. No registers, only memory and pointer to memory, nothing else. Yeah, so the thing is like, well, I have addresses and memory. It's just that, let's say you have a, well, okay, where's the problem happening? The problem is happening actually, I'm starting to think that all my problems came from the decision to use a stack at all. Because the problem is that the virtual threads, which is basically pops up everywhere almost in my language now, because every execution call, when you have a block expression, those have their own virtual threads. And when that happens, they can't access the stack of the outside thread. So they have to kind of share. If an inner thread wants to reference an outer thread's variable, it has to create because the thing is, if let's say we allocate a thing on the heap, we don't know where that thing gets allocated to. We don't know the address in compile time. And so that makes it so that how, like, the problem is, like, how do we reference that address? How do we know what that address is? And that became the issue then. I mean, I guess what you could do, maybe you can have a symbol table in the virtual machine that maps each thing to an address, and then you would do like a lookup. You would have like, yeah, you could do like a lookup there. I guess that could be a way to solve it. The way I did it now is basically I tried to make it as I guess generic as possible and compatible as possible with the existing things, which maybe was a stupid idea, but basically the way I do it right now is like each virtual thread creates their own space in basically their own closure, which is just, you know, an allocated space in the heap. And then the thread has like a local known, compile time known pointer to that space. Because each thread has a stack, a private stack. And it's like the first 4 elements of that stack is always like the same thing. It's like a hard-coded thing. It's like standard in, standard out, standard and then the closure pointer. And then they're using that closure pointer to find where in the heap the closure is. And then the variables referenced inside of the thread will then be compiled into like relative to the closure pointer. So it will be like the first element would be closure 0, the second element would be closure 1, and so on. And so it's kind of like, in order to be able to reference things at all, I'm using like relative known, either from like a stack frame or the closure pointer. And that might be an overly complex solution to maybe a very simple-ish solution, but yeah. But how do you, let's say, so are you keeping a symbol table of like, are you keeping like this identifier is bound to this address, or how do you actually do that? Yo, Baby Yoda, what's up, what's up? Welcome back. How you doing? Yeah, I'm doing good. Doing good. We're talking a little bit about compilers. Yeah, now we're on to this issue here. Okay, I'm pretty sure we need to do this anyway, but this... Okay. So that is the location of the thing. It's kind of like I want to like type annotate this location. Can we do that? We just add an option like a type annotation. Did what you said and rewriting that tool as a web UI. Let's see. Which tool was that? Did you were using like imgui or something or Qt? Was it Qt? ML training pipeline tool. Python Qt, yeah. All right. Yeah, okay, cool. Yeah, I mean, I would say like as long as you're familiar with web UI, like it should be a good choice. Do you do any optimization steps? No. I think it's like I'm focusing on like creating the making the basic stuff work first, and then worry about optimization. I'm not even sure I'm gonna implement garbage collection, to be honest, or any compilation optimization. Maybe I'll do some low hanging fruit, but that's not the focus right now. Like right now is like basically maybe even the architecture of some major stuff in the IR could be changed. Like you were talking about, the memory references and that. And by the way, you didn't answer my question. How are you dealing with referencing variables like let's say, do you have different scopes, for example? Pick Django is popular. Oh, okay. Web UI is okay. I was gonna make my own components, so I just decided to pick a library, but wrote certain widgets myself with JS. There's no way in that certain things need custom JS and CSS. Yeah. All right. Well, I'm more used to like React and I guess you probably could use. I'm not sure. Could you use Django with React? I've never actually used Django. Have you used? Are you using HTMX or something like that? Base code, a clone of Shad CN. Is that like a UI library or? Just search about an identifier in the stack. No scopes. Identifier in the stack? What do you mean by the stack? You don't need to use React, use a Tailwind, use a front. Well, you could use both Tailwind and React. Because I do that all the time. It's a front-end widgets library. It includes animation stuff. Use copy and paste snippets. Use HTMX. Okay. Cool. Like I would say, like React is good when you want to have like reusability of components. Like I'm going to switch to stack of scopes. Each scope is hashtag is identifies key. Okay, yeah. That's what I'm using also, but that's during like compilation. like I also have a stack of scopes in compilation. The problem is what the values represent. It's not like during compile time, but sorry, it's not during runtime. It's during compile time. But maybe that is the key. Like maybe we should actually do that. Maybe have a way to declare things in runtime and have them be looked up in runtime and be able to like push scopes in runtime. So lightweight scissors, run HMS facts, symbols, yeah, scratch, we can. Okay, cool. Yeah, I think that oops, it's kind of interesting because React is like, where is my thing? React is like, sometimes it feels like when you do certain things, it's like, yeah, this could be very optimized, but right now it's like, well, you have these hooks everywhere, and each hook is like, I mean, and then you have the re-renderings and all that. Like sometimes it feels like it just does a whole bunch of unnecessary things. I'm not sure how far along, like because they did work on like a React compiler, but I'm not sure how that's going, what's happening with that. But you know, potentially you could get rid of a lot of like those checks and stuff that's happening like in runtime. But yeah, I don't know. I've tried HTMX a bunch of times, and I always come back to the fact that yeah, it feels very nice in the beginning. It feels very easy to use, and it's easy to get into, and it's easy to kind of, you know, build, you know, the initial parts. But then once it gets a little bit more complicated and you need a little bit more, you know, I don't know, abstraction, reusability, that's when HTMX, for me, kind of breaks down in scalability. I've tried to kind of use some kind of, I've tried to build like, you know, automatic systems that kind of like piece things together with HTMX, but it's like, yeah, that's when you kind of like, okay, well, if I try to build it this way, then I might as well just use React. But then again, I might just not build it correctly. I might be too deep into the React way of doing things, like, but it's like whenever you need to have common components or common functionality that you want to, let's say you have a header that you want to use or reuse that. Maybe it's the wrong thing that I'm reusing. Maybe it's like, okay, well, instead of reusing an entire like HTML snippet, instead we could reuse, you know, CSS classes or functions or whatever. But yeah. Or maybe I'm just not using it correctly. I don't know. They try to make things into components in previous projects, but honestly, I'm at a point where the main issue for me has been having a decent cross-browser set of widgets. Cross-browser set of, okay. Yeah. Yeah, I mean, I guess, I mean, probably they should say somewhere that it should be compatible or something. It's gonna be difficult to look into every component to see that, okay, it's using this CSS thing, so is that compatible? Like search, can I use for every single thing? No, but yeah. Also, are you using AI at any point? I don't know React, but I tried doing SSR components, templating, libs. Oh. Yeah, that does complicate things. Like the server rendering versus component or versus clients. Okay. I think what I want to do here is I just want to add type something something. We can just add like a type expression. God damn it. My components with table classes and the template partial gets parameters for attributes, whatever, I don't know if you get what I mean, and the component rendering logic is all server side. I did that before with HTML with temple. It's like kind of similar one. Give you a little bit, but not really, because again it's SSR. Okay. So are you saying that you're doing that now? You're having partials right now with attributes? Yeah. I mean, yeah, sure. If you don't mind, like, copy pasting a whole bunch of that. The problem is when you want to do, like, when you want to change something later, you have to make sure that, I mean, it also depends on what you want to change. Like, if you just want to change like some CSS thing, you could then you would just have a class you change that. But it's like you want to change more of the layout or more of the, like, and then you have like, okay, well now we have all these pages with copy paste everywhere. I don't know. It just feels like it's like, I don't know. You have to think about the scalability, I guess, in a different way, I guess you would say, if you compare it to React. Because in React is super easy, because then you can just, you know, import it through code, and you can just reuse it like that. I tried to make like a JSX that compiled, well, it kind of created like HTMX compatible or HTMX components that then could be like, you know, they would be just like React, except it didn't compile to React runtime. It compiled to like HTMX. But I partials but don't do component stuff. I mean partials, you could argue that partials are kind of like a component, because I'm using CSS combos. Standard point, it was hard for me to reason about all that. I literally just use Django, whatever partials that are super simple, and just do all my logic on the back end. Right. Yeah. I know it's like different ways of doing things, and I think that once you've done like React for a long time, it's hard to get your mind out of that mindset, for me at least. It's like I've tried starting up like these HTMX projects, but I always reach a point where it's like, man, I wish I could do this, because then these things would be a lot easier. But I think maybe it's just the case of thinking in a different way, trying to it's just I don't have, because it was some years ago now that I tried it last time, but I just remember there was something with, you know, I wanted to have more component based things instead of, you know, copy and pasting a bunch of HTML that you could reuse. You know, I like reusability. That's I guess that's what it boils it down to. I don't want to have to write the same thing over and over. I don't want to have to kind of, I don't know. Maybe I'll try it another time, and maybe I can think of it in another way. Because as I said, like, okay, you can do a compromise. Maybe we can't reuse the whole component, but maybe we can reuse, you know, the logic behind, and the CSS, of course. And that maybe that's enough. Maybe you have to do like a little bit of compromise. Like if you do HTMX, it's more like you do regular 2006 HTML, but add a little bit of live interactivity to it. Yeah, I know. It's just I don't know. It's just that my mind automatically goes to that thing, to a space where, for me to be efficient and to be able to like proceed, I'm kind of, I don't know, how I'm architecturing is different. Yeah. But as I said, like maybe it's more like you could sort of work in that way. It's just that you have to, like, you could work in a smart way. But I'm saying smart, but I really just mean like trying to reuse things more. I was thinking about, you know, then you have things like the web components as well. But the problem is there, they feel like too, like, sort of decoupled from the rest of the application. But yeah. I think, yes, really work component design, like you start atoms and then put them together to make something new. HTMX more replacing huge chunks of code, and it works well. Yeah. maintain state HTML is now all state. Yes, that is true, unless you're using JavaScript. And that's also the thing, like you can use JavaScript in HTMX, it's just that you are in this weird world of raw JavaScript in HTML, which is not where you want to be, basically. That's all I'm gonna say with that. But yeah, HTML doesn't read hosted. I think there's like I think there are like plugins or something for HTMX to kind of try to retain some of those things. I don't remember exactly, but you also have you can combine with Alpine, I believe, but that's also kind of it just feels so hacky. That's the thing. That's what I have against it, I guess. It's like everything feels so hacked together. I've done stuff in the past where PowerShell has JS tagging on the state. Yeah, and then it's like, because it's hacked together like that, it's also you always get the feeling back in your mind that's okay, well, is some bug gonna pop up later, sooner or later, with this shit that is gonna be super annoying to deal with. Hello, Buzztronic. Is this the font size you use normally? No, it's just for the stream. But my eyesight is actually not getting better, so it's good for me. It's like even at this size, the edges, I have to, if I move my eyes around, the edges are kind of moving around a little bit. I'm only using it because it's lightweight. Yeah. I mean, it's super productive if you do like, if you know how to use it. Also, I like the idea of going back to basic instead of building another layer on top. You go back to a more basic. What I mean is, you go back to more native stuff, native, JavaScript, HTML, and so on. Instead of building on top of it another layer on top, you go below. Sometimes that's really good, and sometimes it also makes you miss some of the features that you're missing out of. But yeah, it's interesting. Kind of live terminal. I'm making a kind of live terminal because I have a job queue for the Amazon workflow. No clue how I can use HTMX for that. Guess the only way is to poll the server. You could use polling. You could use WebSockets. It's probably good as well, because that gives you more. WebSockets are good for real-time updates that happen quickly. You could also just use polling, I guess, which polls like events or something. You can replay it if you want to do like that, maybe. I don't know. I also did like a terminal, sort of terminal emulator. Not really, but basically to be able to display a terminal results. And that included like things like ANSI codes and color and stuff. That was kind of interesting. That's when I learned that what ANSI code actually was. I didn't even know what that was about. Penguin, as that for AI usage, at least potentially can decrease the advance of human labor made on the product. The more advanced the product made is, the more profitable the investments of the capital. Oh. I'm not sure what you mean there. I'm not sure what that means, Penguin, to be honest. Oh, you do parse ANSI codes. Okay, cool. Now it's like, for now, like it's for me, not worrying about security. Yeah, worry about that later. Just don't execute things, strings from the client directly in your shell. Or yeah, I mean it's pretty simple. I think actually it's just that don't have any strings at all that come, like don't deal with strings from the client, basically. That probably solves the issue, or most issues. What is this text editor? It is NeoVim. Let's see. What are we doing here? What is happening? Oh yeah, that's right. So this returns this. What I would like to do is also set a type. I'm gonna say typed, and I'm gonna say that. Okay, so now we can do typed. All right, now what is this? So it's gonna be like a struct type. Yeah, and this struct type is basically defined somewhere. It's gonna be like, you know, this hard-coded thing. So this is gonna be whoops, execution handles struct type. No declarations. Okay, so fields is gonna have So this is gonna be like the thread handle. No, the first one is executable. I guess closable, whatever. I'm gonna say closable. And then this one is a something. As far as I remember, Jensen Huang said that AI usage. I said Jensen like, because that's like a common Scandinavian name. Okay, anyway, that AI usage can decrease work time to 4 hours per day. Did you see these changes? I mean, I think what's gonna happen is more like we're gonna keep the work time as it is, and then the companies are gonna say, well, now we can just increase productivity. In France, it has been calculated that this percentage development production is an average. I mean, I don't know. There might be some weird. I'm just thinking short term here. Presentation development of production, an average working period of 5 hours a day by every person capable of work could suffice for the satisfaction of all the material interests of society, notwithstanding time saved by perfecting the machinery. I mean, right now it's like, how many jobs right now are actually made, or how many jobs in society right now is for the survival of humanity? I mean, there's, you know, when the revolution, like the Industrial Revolution came, and there was like, you know, how many jobs got lost when machines started to do the work of, you know, a lot of people on the farms. But what did they have to do? They had to find other things to do, even if it was just, it's not really necessary for the survival of humanity. I mean, what I'm trying to say is that, you know, if we already are at the point where, you know, only a few people have to work for us to survive, it's just that that's just not what's happening. People praise libraries and people hate of the best weird HMS was being shit talked, but I enjoyed decent stuff with it. Same with Bootstrap, I used to hate it myself, but the way they're doing things makes sense. I mean, yeah, it's a really nice libraries for the correct, like if you're using it for the in like correct way. The thing is, I think that nowadays most browsers look the same. Like if you're trying to style something, it looks the same in most browsers. I think there's some things that doesn't. But it's also like, you know, Tailwind has like a base line styling that tries to kind of make things look the same. I know there's an issue there. I think in Chrome there's like it has like a margin on the body or something at the start. I always reset that to 0. And some also don't have that. For example, but some things is like, okay, file drop zone. I mean, yeah, that doesn't really matter. Like, okay, who cares about file drop? Like, that things like that probably should be you know, specific to different operating systems or browsers, just because of familiarity of the person who's using it. So some of those things is like, it doesn't really matter, and it's probably better. Okay, type expression. What are you actually? I mean, I don't think we have this type. It's like a. It's just. Well, it's actually. It's just. It's kind of like just like a number. Actually, this doesn't really matter. We don't really care about the type here. So I'm just gonna say it's a number. It's an integer. Primitive. Okay. So that's one of the things. And then we have the second one. And this one is the thread. And it's got the same thing. Okay. So that is our execution handles struct type, which is not a type, so we'll do that. Actually, it's not even a thing. There we go. Okay, and now, whoops, you are this. Okay, so now it's typed, and if we wish, we could look at the type and see, okay, it's this type. Okay, that we know how to handle it in certain situations. Very good. What the? Okay, there we go. Personally, kind of despise the way default inputs look and work. Not just files, but all of them. And you pretty much need JS to make it look and function for a better UX, and it's real time consuming to make. Yeah, I mean that's the thing. It's yeah. I think that's why most. I think, like, I mean, if you go to any website right now, look at the inputs. Like, there's barely any, you know, things done to that. Maybe the color, like the background color, but basically, well, or yeah, there's also like some have the kind of the outline, like a weird blue outline when you have it focused. I don't like that, but anyway, it's. I just think most sites have like the built-in style, especially for inputs. There might be some things change, like, but for the text part, maybe the border, you can have like, you know, inset icon buttons. But have you yeah, but then you have like, you know, Bootstrap should work with that. And then you also have like Material UI, like other UI libraries like that. Set those. You can hide it. Watch for on drag enter other events on a div. And then set those files on the hidden input. Oh, yeah, that just sounds too too shitty. I mean, too shitty to develop. It sounds shitty to develop. That's what I'm trying to say. Yeah. Okay, let's see. I'm gonna do a little bit more and we'll call it here. Okay, so also now we're here looking at these colors here. Well, I didn't really look at it, but I saw it with my eyes. I just realized, well, I was exploring the standard library Zig at some point, and I saw that it actually has built-in ANSI color stuff. Now, where was that actually? Was it in ASCII or terminal? IO. Was it over here? TTY color. Look at this. There's like colors here. I didn't even know, and there's even like reset, I think. This, and then this is used. Look at this, it's mapped to the ANSI code. So I didn't know that this was here, but this is really cool because then you can use it. I guess the color would have maybe a format function. No. Actually, how would you use it? Set color for what on the config? Okay, so we got like a writer. Okay, so you create a config. Provide simple functionality management terminals such as calling that. Okay. So you would like create this config. What is this though? Config detect. Okay, so I guess you would do like, you know, standard in or something. Isn't it better standard out? Yeah, standard out. Okay, and then I guess you would get the config for that, and then you could use like, you know, set color. I guess it would just write it directly to the thing. So that's pretty cool. So if I knew that existed, I wouldn't build these things because I built this like rainbow. It wasn't that huge of a deal though. Basically, it's just a kind of the same thing. It's just I just did these ones. Yeah. Anyway. I did do SSR components to write for I wrote out an article about a spinner I made. I'm not against doing that as well. Oh. Well, congrats on making an article. I've never done that. Cool. Oh, there you go. Alpine JS. Yeah. All right. Anyway, let's bring this home. I think. Okay, where is this? So okay. So what this is gonna do is gonna be like is waitable, and we're gonna say that okay, well we got a location, and if the location is a register, we deem it to be waitable. But this isn't always the case. Right now it's actually like a stack pointer. What I'm gonna say is otherwise we're gonna say if if this is equal to this, I'm gonna do this is type and then there's like a meta equal function which will depending on the type you put in is going to use a different equality algorithm here. And if it's a struct, it's going to like deep check here. So it's going through all the fields and checking and doing a recursive deep field check here. So that is exactly what we want, I think. So it's going to be like self type expression is equal to type expression. Okay. Now we have that. I think what Zig does is that it stores every like thing in an indexed like node list or something, and then you can just have the ID. So every type probably has like an ID that you could check instead, but whatever. Let's I'm just gonna do it like this. So this would be like is type okay, and if it is, then I'm returning the location that is the waitable location. And what is that? Well, that's gonna be like a field access sort of on this location, because the field is this one. We're trying to wait for the thread to close. So what do we do here? What do we do? What do we do? I think we have field. Wait, where? Yeah. Oh, it's not self field. It's just field address. No, we don't have that. This is only for compile time known addresses. I mean, This is like a page made in that way. It's just SSR and Tailwind. All right, cool. So the buttons on the left, do they go to different pages, like URLs? Yeah, I mean, it is super easy to build this sort of super basic, you know, forms and stuff. Like HTMX is super nice for things like this. I don't remember what was the thing I was trying to build. I mean, I think I was building more I think that was more, I don't know. I don't remember. Anyway, I was trying to build like a super advanced, kind of like a Next.js but with HTMX. I'm not sure if you know what Next.js is, but basically, you know, one of those, like, you know, you have SvelteKit or what was the old one called, the React one, Gatsby. But basically, you have like a folder structure that determines how your app works, kind of. So instead of having like in the code you define the routes or whatever, you would have a folder called like pages, for example, and in the, or routes or whatever, and then in that folder every file would be its own, you know, route or its own page, and then you can. So it was super easy to just create like the structure of the page using that. I mean, that's one way of doing it, I guess, but that is like whole frameworks are built around that principle to name your file structure to match the URL routes of your page. And then also Next.js has, you know, SSR and a bunch of other stuff built in, of course. I think it's still like one of the most, you know, it's like very active work done right now. But I was basically trying to build something like that for HTMX so that I could kind of, and also like, yeah, so that I could reuse basically HTMX components. I was trying to build I built like a JSX compiler that compiled to HTMX. But then, and also like, you know, all this, you know, the kind of the live reload and caching and all that. So all this shit. Yeah, I've seen that word before. I don't remember what it was. Hypermedia's engine of application state. Okay. I googled it and this is what it says. Är en begränsning inom restarkitekturen där API-svar innehåller hypermedia-länkar som dynamiskt guidar klienten till tillgängliga åtgärder. It's in Swedish. All right. I'm just gonna hard code this right now. So how could we do this? I think we might have to. I mean, no, because okay. Let's actually could we just dereference this? And that would just point us to the first item. That would be a pointer in itself, I believe. I'm just gonna return dereference here. All right. Okay, well, it got compiled, so we'll just see if we're gonna wait for the correct thing here. Oh, probably not. Now here we're trying to set this to R. Oh, +8. Oh, that was wrong. What? I feel like every re-implementation of a client-side router sucks. Why not use the built-in thing? You mean, what do you mean by the built-in thing? Like, do you mean just using, like, you know, anchor tags, and then, because, you know, the thing is sent then to the server, which decides what to, you know, what route to have, and how do you define that route? Like, yeah, you can have it on the back-end side. You can also have it on the front-end side. That will catch it before it gets used. But that would be an SPA, sort of. Well, it doesn't have to be an SPA, but SPAs use that to block the thing. Yeah, but the thing is, like, if you're using, like, let's say you're using Next.js, so the routes aren't necessarily only for client. They could be like API routes as well. You can have, so in the file system you would have like you could have a folder called API or something, and then you could have a file in there that has the code to handle that API call. That's sort of how it works. Or you can also have a file called, like, I think Next.js uses different file names, like hard-coded, like special file names, like layout dot whatever, JS, TS, whatever you're using, and that would be kind of the layout of the page, and then you would also have the page.ts, and it's just a way to define what routes are available and what parts of the code is, like, you know, used for which routes, or yeah, the handles and stuff. But it is taped together sort of with magic, because Next.js compiles, sort of takes those files and compiles them, sort of. I mean, it when it starts its runtime, it has to know what routes there are and set that up, and you can have like configurations that it needs to read from those files. It also needs to handle like imports, like if you're importing from other files. Let's say you're on the client side and you import an image. That image could go through some further processing. So it's like there's a lot of things happening in that framework. But just for the routes themselves, it's just one way of defining it. So you don't have to have like a separate file. Well, you don't need to have a separate file in that case to define the routes. If you're doing things like, you know, React router or something like that. Or on the backend side, you're using kind of, let's say you're using Express, you would still have to, you know, define all the routes and their handlers. This is just another way to kind of organize it. And, you know, whatever floats. Fork. Okay, so why is this +6? We only have 4 items on the stack. It is +6 though. Why is it only 4 things on the stack? No, there is not only 4 things. So there's like 7 things. That should be fine. Yeah. So now we go down to 6. Is it because we're popping now? Oh, it's because we're popping that. Okay, there's a off balance thing here. I'm pretty sure. Where is that happening? I think it's happening in the execution call. Yeah, it's like this ref is not, it's not rebalanced. Exec handle ref. Wait, no, that's the inner part. Yeah. So we need to pop here. I'm gonna pop there. That will pop this ref. Because it's really only used to be able to set this here. Yeah. So that is then popped. Actually, we could just pop it directly here. We don't even need to store it here. Yeah. Okay, let's see how that looks. I have used modern FS based router set. Maybe they glue shit well. I mean, I think we've gone through a number of iterations on those. To be fair, the Next.js does work pretty well, I would say, from what I've seen, and it is being used in many projects now. So, yeah, it's one of the better ones that I've worked with. But it's not. I mean, there are trade-offs, of course, and there's like other ones as well that is probably also just as good, but that's the one that I've been working with. But yeah, I mean, it's also like I think sometimes you feel like, oh, why not just go back to the basics? You know, why do we need all this complex shit? Like, do we really need all this stuff? Because it's just so complex sometimes. If you look at how the engine works, there's just so much thing happening, and is it even worth it? Do we even need this? Do we need to wait for this to compile and so on? But you know, it depends It depends, I would say. And you know, once you get used to it, it's like you're gonna be productive in that as well. But sometimes you feel like, yeah, why do we need all this complexity? But there are reasons, though. But you know, it's always a trade-off. Self-pop expected one organ. Okay. Oh, source. Right. And then we don't care about this. The idea behind HTMX is, do you get HTML anyway as a result? Any frameworks, so why not short circuit? But I understand, like, you might want to do advanced stuff in the client, whether it be animation, state-based, state-related stuff. You need to see an example, like something you could do in those frames you can't do normally. I mean, yeah, I mean, you can do most things, I would say, with HTMX. It's also like, it's not only what you can do, like in the HTML, like in the application. It's also how you organize the code. And, you know, scale it up and, you know, feeling like you're productive and how you're thinking about the code. I think it's also that. Like, HTMX is extremely good for, you know, if you're working with, like, you're building something fast and then you throw it away, you build something fast. You know, something like that. I don't know. But, yeah, I don't know. I know it's possible to build like real large good projects that feel like, you know, any other React app, whatever, in HTMX, because I've seen it. You know, there's a really nice talk that I saw of a company that showed like their whole application. They rebuilt it in HTMX and it looked super nice. And it was super optimized, or it looked super efficient and really nice. I don't know if they shared any code or anything. So I know it's possible. And they use Django as well, like Django plus HTMX. I'm not sure what else they use, and I don't remember now. It was like a couple of years ago, I think I saw the video or something. And it's like, yeah, if you need a more advanced, you know, client-side code, you can build it in JS, CSS. Like, it's fully possible. You can build like a web component, you know, but yeah, you can do it. But I'm just gonna leave a button there. What did we do? We added a pop, right? Oh, are you using web components, or are you making your own web components? Pop, execute, ref. See, this is +8. Where are we on the stack right now? We're not even close. Why does it say like +8? I did add a pop. It should have at least gone down one. Did I miss something here? I thought it said +8 anyway first. Before. +6 is fine. 2 pops. No. Okay, let's see. How many? What are we doing here? We have execution handles. Now that is actually that is just return straight away, but that shouldn't really matter, I don't think. Maybe it does, I don't know. Oh yeah, we have the identifier ref. Yeah, that one we could just delete straight away. Where's that happening? I think it's happening here. Why is that saved? Result ref. Oh, it's because it's being used here. Okay, that's not great though. Alright, see you, Penguin. Implement an editor with a web component. Okay, cool. Initial state passed as an attribute. Does IX stuff. But it's back to basic. It's native. It's not really nice to work with though. The only thing that sucks is the styles in the shadow DOM are separate. I never liked the idea of shadow DOM. Like it's just confusing. I don't even know why it's there. Why do we have like what is it even used for? Like why do we need to like at like the web component, why does all web components have to do with like a shadow DOM thing? It just feels weird. Is it just to have like a secure separate like template version of the thing? Like it feels like there should be another way. I don't know. It just feels weird. And then there's like different ways to make your shadow DOM work as well. It was never intuitive for me. It's for having a sandbox thing in the page without iframes. So is it just so that the web components has like their own, like, you know, the isolated world, like their isolated context, so it's gonna like kind of like a container. The style is separate from the rest of the page. Yeah. So okay. So but if you have your component in your HTML, I mean, if you make an instance of the component, it does not. It can't access like outside styles or classes. That's also super weird, and it makes it bad, in my opinion.
there has to be a way to fix to go to like make it work, right? Web. I mean, it's like, yeah, sometimes you do want that, sometimes you don't. Okay, anyway. Because the idea is pretty cool. And I mean, it does have like reactivity and stuff. If you set it up correctly. But it just feels so complicated, unnecessarily complicated, and I don't know, hard to work with. Anyway, okay, I think I'm gonna leave it. I'm gonna call it here. It's like I'm so close to making like a consume function that will pop the thing that we get out. But then it's like, then we have to be vigilant and consume everything as soon as we can. And I'm not even sure if it's worth it. Or if we can just ignore the issue. Because it's like, yeah, this is from here. Of course, actually, what we could say is like, we know what value pass in here. So we can say that, okay, well, we know that it's the R register. So we know that there is a thing here. This is on the stack. So we know that, okay? And we know that the declaration, the problem is, I think maybe the declaration, no, yeah, the result is this dereferenced. And so this variable, the lifetime of this stack, of this thing, needs to be taken into account. So we can't just pop it here. We have to wait until the thread, it basically is done over here before we pop. So I think we pop here, and I'm gonna say this is the identifier ref that we pop there. Okay. No, wait. This is the outside. What the hell? No, it's not. Yes, it is. No, yeah. Or I mean, this is the inside of the thread. No, okay. So we actually have to wait even longer here. Oh man. Maybe we can change it though. Maybe we can say actually we could just do execution handles dereferenced, and now we don't have a reference to the stack anymore, and we don't even have a thing that we need to pop. Okay. So that saved us complexity and good things. Okay. You have to include a CSS file in the shadow DOM style. I mean, I guess it's cached I mean, or potentially cached, so that's fine, but it feels unnecessary. It feels like it should. I mean, I understand why you would want some components to have like separate context, because some components are meant to be, you know, imported from like a library, and it should always work in a separate way, or you import the whole application or something. But you know, if you're trying to build like a reusable library of your own components and they make sense to have a shared CSS, then it's just so much worse to work with. Yeah. All right. But then again, it's probably, if you find some workaround, it could be also a very, you know, valid solution to the issue. I mean, what about a JSX compiler for web components that like builds web components? That has to exist somewhere. Just to make things easier. Just to make things easier, like just to so you can build things more easily. And then you can, you know, you can get just a whole bunch of nice things when you're developing. WebJSX. Yeah, I mean, I knew it had to exist. What about TSX? I need TSX though. I mean, whatever. This is really nice. Are you using that? Are you using WebJSX? All right. How do you feel about that? I don't know. Yeah, I like things like this. It's if it works, I should say. Like if it works. If you encounter some kind of bug or something that blocks you, that is the worst feeling ever. But okay, it does have TypeScript as well. Wait, or does it? TypeScript will complain, custom element is not found. Oh. Okay, so I guess it does work with TypeScript. You just have to like manually add the elements or something. I don't know. All right. Cool. Okay, 4 more minutes. I'll go until 2 o'clock. Let's see if we can make this work here. Okay, so this should get rid of this ref in here. So now I think we're 1 step closer. Should say +5. Okay, wait. Is that correct? Yes. No, it's down over. Okay, +7. We're looking at the stack. It's like we're 2 off. Where are those things? Are we missing like something here? Using HTMX, you want to use attributes for state. Yeah. I could and yeah, and Alpine works good. The one thing that I have against like HTMX plus Alpine is just it just feels hacky, and there's no like static analysis. But yeah, I guess, you know, if you're building it like that, it's more like you're testing that it works. But you still have to use the Web Components API with WebJSX. But, well, the API? So you define the element that compiles to, that registers the element as well, right? Select the container in the real DOM. Apply WebJSX apply diff. Alpine is kind of overrated. Like, I would rather just make stuff with web components. Why? Why? I thought the whole point of Alpine is like so you don't have to do custom things like that. Like you could just work with as long as you can. Like you would just work with the HTML directly. It's like I think the point is to reduce the amount of JavaScript you write. Right? And HTMX also, you know, goes there. So I think Alpine plus HTMX makes sense. It makes they strengthen that aspect of it. Well, it's useful to make a pop-ups and basic stuff like mirroring values. Maybe I will revisit with this WebJSX thing, because that looks cool. However, I would rather have... Well, maybe there's like a... Wait. JSX to HTMX plus Alpine. All right. Anyway, well, I'm out of time. I have to write down what's happening here. I'll write it down here. Figure out how we can avoid stack ref erroneous pointer plus 7 when there are only 5 max. Alright. Cool. It's good library for interaction over your whole page or like gluing stuff together. Yeah. If you own routing, you can use WebJSX router. JSX Pine. JSX Pine is a set of reusable components for building web applications with JSX and Alpine JS. It is intended to give JS developers two powerful tools to create fast and efficient user interfaces without the need of SPA framework libraries. Wow. Okay, that is interesting. And then you can, and then it has like an HTMX thing as well. But I mean, so JSX, Alpine, Pine's UI combines Alpine JS and Tailwind. This has everything. Shad, CNUI. Maybe I'll try this one time. What the hell? How did you find this? It doesn't seem to be that active anymore. Unfortunately. Alright, see you, Vincent. Yeah, Google. I mean, it has... I'm not bashing on it, but it has like one store, and 2 years ago, last commit. It does have like 250 commits. So it might not be like super robust, I guess, but I mean, you can always try it. It would be better if it was actively maintained. It looks like an incredible idea. And they even have like a homepage. I mean, maybe, you know, maybe it's perfect. Maybe it's like fulfilled its duty. Like it's using all these other, it's basically just gluing other things together, so that maybe that's just what it is. It doesn't need to be anything else. I don't know. What's the size of your average page with this? What do you mean? Yeah, I mean, it's just gonna be just like I'm gonna guess it's just gonna be just like building your own, you know, HTMX plus Alpine, except it might, you know, bloat it a little bit depending on how it compiles it. But I don't think it's gonna be that bad. Yeah. And also, like, crucially, you know, it's only going to use the runtimes of HTMX, which is very small, and Alpine JS, which I think is also very small runtime. So, I mean, compared to React, there's no contest. I think React is like, yeah, it's a lot. I'm not sure about Pine's UI and Shad CN UI, but that's just like, you know, UI stuff. So it's like necessary evil. 19 kilobytes. Here it says React is actually 40 gzipped. But I mean, it's not only that, it's also like, you know, the speed and stuff. Yeah, I just want to have an easy time doing the things. Also, it's like, I think they actually improved React a lot, like the size of it, because that was a huge issue before, I think. Yeah, I want my auto completions. I want, you know, documentation. I don't want to have to constantly look things up. No, but yeah, sometimes when you work with things, it's like, but the thing is, like, if you're working with, you know, if you learn like HTMX, I think you're gonna pretty quickly get up to speed where you don't actually have to look up anything, because you know the HTML, you know the CSS, you know the, you know, HTMX stuff. And then the rest, like the Alpine, if you use JSX Pine, I guess you don't even have to touch Alpine at all. You just use JSX. So, man, I really want to try that at some point. All right. But that's going to be it for this time. So, yeah, thanks for joining me. Let's see. Do you want to get sent away? Or should we just disperse? Is it a necessary ritual to raid someone? Also, Bustronic, thanks for the follow like 1 hour ago. Oh shit, Baby Yoda, thanks for the 100 bits cheer. I think that's the first cheer I got. Thank you. 52 minutes ago. I don't read this. I don't have like yeah. Whatever. I'll see you later. Have a nice day. Bye bye.